Hey everyone, here's lecture 3 for Eco 208, hopefully with a few technological improvements. So I think definitely the audio will be better. I think the video is of a higher quality, but I haven't worked out the lagging yet, so I'm sorry about that. But hopefully I'll have that improved for next week. But today we're going to talk about business cycle facts. So this is going to be a bit of a shorter lecture today. It's going to be the last sort of introductory lecture. We're just going to be talking about facts. There's not a lot of theory in this. And then next week, we're going to really dive into the theory. So today, what are we going to talk about? Well, first, we're going to talk about how we define the business cycle. And I'm going to suggest that the way this is defined kind of changes our answers to different questions about the business cycle. Then we're going to talk about business cycle facts themselves. So this is going to follow the textbook pretty closely. So we're going to talk about what variables move over the business cycle and how. Do they say lead GDP? So do changes in them come before GDP or after GDP, or do these changes happen at the same time? Questions like that. And then finally, we're going to talk about something that your textbook brings up, which is about, can we predict recessions? So these business cycle movements, are they predictable in any way? And so your textbook has sort of one idea of this, and I'll maybe push back a bit on it. And it should be fun. So without further ado, here is lecture number 3 on business cycle facts. So as promised, the first question we have to ask, when we're doing any science, any social science, we need to define our terms. So we have to kind of ask, well, what do we mean by business cycles? And so I'm going to talk about maybe traditionally how these were thought of, what business cycles were. And then I'm going to talk about how business cycles are defined in your textbook and how many sort of modern economists talk about business cycles. And the two aren't exactly the same. So economists, and no doubt regular people, recognized early on that there were these ups and downs in the economy. So there were times when things were good. There were lots of jobs when incomes were high. And conversely, there were times when things were bad, when incomes were low, there weren't a lot of jobs to be had, profits were low, and so on. And indeed, these have existed sort of throughout the history of capitalism. And if you don't believe me, just go to Wikipedia and look up history of business cycles. And so here on the next slide, I've copied down all of the recessions or crises that were listed, economic crises that were listed for the United States between 1700 and 2000. So a 300-year period. So here you go. Here's the list of, according to Wikipedia, of all of the US downturns, US recessions. And so you'll see that, it's really been a feature of the US economy for these 300 years. They're pretty recurrent. All kinds of different ones. And including in the 1900s, some you might recognize, like the Great Depression, the 1970s oil crisis. There was 2 also in the 1980s and the 1990s. And if we extended this into the 2000s, of course, you'd have the Great Recession, as well as another smaller one, the dot-com bubble bursting in 2000. So when we talk about these business cycles, why are they cycles? Well, really we're thinking about the economy as going through these periods of booms and bust. Like there's this wave-like economic pattern. There's some times when economic activity is rising or high, where you can think of here maybe economic activity as employment or profits or wages or incomes. And there are other times when it's going down, right? And this might be a recession, for example. And you get this kind of these movements, these booms and busts in the economy. And indeed, you can see this if you look at statistics. So here I have a US unemployment rate. And you can see that it follows this kind of wave-like pattern, right? In recessions, it's the opposite of what we saw here before, because in recessions, unemployment is going up rather than going down. But still, in recessions, which here are shaded in gray, unemployment goes up, and then it falls, and then it goes up, and it falls, and it goes up, and it falls, and it goes up. It's this wave-like pattern, these sort of cycles in employment. And you can see the same thing looking at, here I have real per capita GDP, with the caveat that it also grows over time. And we'll come back to sort of how to address this in a second. But you can see it, right? I mean, it's going up. Oh, there's a period of recession where it falls. It's going up, it falls. So you have these sort of same wave-like patterns, as well as the fact that it's sort of growing over time. Now, so what do we mean then when we talk about business cycles? So I said that it's differed over time. Now, early on, economists really were interested in explaining the causes of these periods of recession and depression. And so when they talked about the business cycle, this was it. It was about how do we explain these times when everything seems to collapse, everything seems to explode in the economy. And so kind of very descriptively, they referred to these as crises. It was a crisis of the economy, or alternatively as a commercial crisis, commercial crises. And one can even put up to Keynes in this boat. I mean, so Keynes in the general theory was trying to explain, one, why we have these changes in unemployment and also why they can last so long, right? It was really about explaining things like the Great Depression. Now, recall that in the 1970s, there was this change that ushered in a new school of economics, which is referred to as the New Classical School. And one of the main ideas of this school, recall, was that fluctuations in business activity were somehow rational. There are these equilibrium outcomes of changes in prices and wages and so on. And so unemployment wasn't unwanted, it wasn't involuntary. People weren't unemployed because they couldn't find a job. It was just that they were responding to these changes in prices and wages and so on and choosing not to work. Likewise, consumption might change because faced with changes in prices and interest rates, people were choosing to consume less now, and so on. So they had this idea of business activity and changes in this business activity as being rational. And so here I include a quote from two economists who we're going to follow throughout this lecture. These were two new classical economists, Robert Hodrick and Ed Prescott. And so they say, the failure of Keynesian theory in the 1970s has caused many economists to want to return to the study of business cycles as equilibrium phenomenon. And so here I just repeat what I said. All fluctuations in employment, in hours worked, in GDP, etc., these were just the result of equilibrium phenomenon. So they weren't necessarily crises. You know, this word kind of disappeared. We weren't talking about crises anymore. These were just fluctuations, rational fluctuations. And so they didn't require an explanation that was any different than normal changes in prices and quantities of anything, right? This wasn't some special event, these depressions and recessions. They were just fluctuations that we want to explain. And I'll show you that, in fact, their conception of the business cycle was far more broad than just looking at recessions and depressions. So no longer it was about explaining crises. Instead, they were interested in explaining any fluctuations in variables, macro variables, around the trend. Okay, and so as I said, as we'll see, this leads to a different conception of the business cycle than just looking at, say, depressions and recessions. So what do we mean by fluctuations around the trend? So what's the trend? The trend accounts for the fact that an economy is growing over time. So remember, we saw that graph of real GDP per capita. And yeah, there were these fluctuations, these kind of wave-like patterns, but also it was growing. And so we have to somehow account for this fact when we're talking about fluctuations, right? And so the way your textbook put it is this. It's often simpler and more productive to consider separately the theory that explains trend growth and the theory that explains business cycles, which are deviations from trend growth. And so the idea here is that there's sort of two sets of factors, two sets of economic factors. There's one set that's leading to the growth in the economy over time. And this is what we look at when we talk about growth theory. What's causing the economy to grow? And then there's some other set of factors that are causing the economy to fluctuate around that trend growth, around that growth over time. And we need to somehow separate these so that in one sense, in one kind of part of the discipline, we talk about what's causing the growth in that trend. And in the other discipline, we're talking about what's causing those fluctuations. So here's what I mean. You can imagine that remember we had our series before that was kind of flat over time, but was fluctuating, had those wave-like patterns. Now imagine we still have those wave-like patterns, but the series is also increasing over time, like GDP, right? GDP is increasing over time, but we also have these periods where, say, it's decreasing. Well, then we might say that, okay, here's the actual series, but it has some trend rate of growth. So because of those factors that are leading the economy to grow, it's kind of on average growing at this rate. On average, say, growing at 2% a year. And then we want to remove the effects of that trend when we talk about just the cyclical parts, just the parts that are fluctuating over time. And so that's going to be called detrending a series. And really all that means is we subtract the trend from each value of the series. So at any point in time, if I go back to my chart, at any point in time, to get the detrended series, we take the actual series value, given here, and we subtract the value of the trend at that point in time. And in that way, we're kind of getting rid of the effects of this trend from the series. So for example, if we want to detrend GDP, you just take GDP in some years, so say GDP in 2020, and subtract the trend from that. And once we do that, suddenly we have this kind of flat-looking series again, which oscillates around 0. And this would be our detrended series. Now this brings up the question, of course, how do we find the trend? Well, a common method, and one that's used particularly by economists, is what's called the Hodrick-Prescott filter. And it's named after those same two economists who we met earlier, Ed Prescott, who I should mention won the Nobel Prize in economics, and Robert Hodrick. And as I mentioned, these are two new classical economists, from this period we've been talking about. And so from their article where they introduce this, from their paper, they say the maintained hypothesis, based upon growth theory considerations, is that the growth component of aggregate economic time series varies smoothly over time. And we're going to see particularly what they mean by this, but basically they mean those components of the economy, those factors in the economy that are leading the economy to grow, don't change very quickly. So if we're growing at 2% this year, we're probably going to be growing at something close to 2% next year as well. That doesn't change quickly over time. Those things that do change quickly are these cyclical elements, these things that lead to business cycle fluctuations. And so I'll show you exactly what they mean in these next slides. So to find the trend using the HP filter, it's the result of a minimization problem. And this is the minimization problem. So what you're doing here is you're choosing the trend in each period, where the trend is given by GT. Okay, so for every period T, I'm choosing the value of the trend to minimize the following, where here YT is the value of the actual series. Now, to simplify, there's really sort of two components to this. There are two major terms. The first one is the difference between the actual series and the trend. So remember that we're minimizing this. So we want the difference between, this is squared, we want the squared difference between the trend and the actual series to be small. Okay, this makes sense, right? We want the trend to generally be close to the actual series. So we want this to be small. Now obviously we could make this incredibly small, in fact 0, if we just made the trend equal to the actual series at every point in time. And this is where this second component comes in. This second term explains why we don't do that. The second term is the difference between the slopes in any 2 consecutive years of the trend component. So again, remember we're minimizing, so we don't want this term to be large. So in other words, we don't want the slope of the trend component to change a lot over time. And this again speaks to what I said before, right? We're saying in general, we assume that if we're growing at about 2% this year, that is if the trend growth rate is 2% this year, then probably those same factors, those same growth factors will lead us to grow about 2% the next year. So this says, yes, make the trend very close to the actual series, but don't allow the slope of the trend to vary a lot from year to year, from period to period. And so that's what I say here. There's this trade-off between the two components. So one, we want the trend to be close to the actual value. That's our first term. But also we don't want the trend to change slope too quickly, which is our second term. And so we're picking the trend, gt, in each period to minimize this entire sum. And lambda here governs how much we care about this second term relative to the first. So the higher is lambda, the more we care about the slope changing. So the more we want the slope to change less. And so I'll show you exactly how this lambda term kind of operates in the next few slides. So to show you, here's my made up series. I just made this up in MATLAB. I plotted it. Here's my series. And we're going to apply an HP filter to it. So we're going to take the trend component. We're going to solve for the trend component using this expression here. And first we're going to do it with lambda equals to 1600. And that's kind of standard. If you want to know why, please consult their article. It's maybe a little complicated, but otherwise take my word for it that this is kind of the standard value of lambda, depending on the situation. Again, perhaps you should refer to the article. But in any case, so at lambda 1600, what does our trend look like? Well, look, it generally follows the movements of the series, but not too closely, right? It's not going up and down with every sort of oscillation in the series, but it's generally following it up. It says, well, in general, it's growing, right? In general, it's increasing. Okay, what if we pick a different lambda? So a small lambda, okay? Remember, lambda is how much we care about the slope changing. So a small lambda means I don't care as much if the slope of the trend line changes. Here's what that looks like with lambda 10. Because we don't care about the slope changing as much, you'll notice that that's what happens. It now tracks the series much closer because we're penalizing it less for changing slope. And so as a result, it's kind of even following these oscillations up and down in the series. And so maybe such a small lambda isn't great to figure out what the trend growth is, what we're kind of growing at on average in any year. And then what about the opposite? What if we pick a really big lambda? Lambda equals to infinity, for example. Well, remember, again, lambda is how much we care about this change in slope term. So if we care a lot about how much the slope changes, well, it won't change at all. And then we get this straight line. And in fact, for those of you that have taken Eco 220, this essentially becomes the OLS line, the line of best fit for this series. So you get a straight line which kind of, as best as it can, minimizes this distance. So that's the HP filter. So what does it look like in practice? Well, here's a series. This comes from your textbook. This is Canadian per capita GDP, going back to the 1800s. And let's apply an HP filter. Well, it looks something like this. So the actual series now is in red, and the trend is in blue. So just as we saw before, it kind of tracks the series without kind of going up and down with every little oscillation. And then if you detrend it, so this is the exact same thing, but now we're going to subtract the trend from every value of the actual series. It looks something like this. So you get these sharp oscillations, right? These sharp ups and downs, as you can see. Maybe less wave-like and more kind of almost like a heartbeat. And this is really going to show you why this conception of the business cycle, why defining business cycle, or the business cycle as these fluctuations around trend, is different than this earlier view of the business cycle as being about crises, as being about recessions and depressions. And so to show you, we're going to zoom in here, 1960 to present. And I believe this is also different. The last series was log GDP per capita. This is just GDP per capita. But still, we've done the same thing. We've detrended the series. And now included here are the most recent 4 recessions. I mean, this textbook was written before our current situation, so we don't have here data for 2020, but you can imagine it's probably going down. But prior to that, here are the 4 most recent recessions. Notice that this is only a subset of the sort of downturns we see in the detrended series. So yes, when there are recessions, we see downturns in our series. But there are also these other fluctuations now that we wouldn't pick up if we were just looking at recessions or depressions, or what used to be referred to as crises. So in this sense, this view of business cycles is much broader. It includes, yes, the recessions and depressions, but also more. Also these other downturns in deviations from trend. So this is what I say here. There are far more peaks and troughs than if we look at recessions. And by peaks, I mean sort of local maxima of the series. And troughs, I mean local minima. So peaks are sort of when it turns at the top, and troughs are when it turns at the bottom. So there are far more times, there are far more sort of downturns in the series than there are recessions. And so why is this? Well, deviations from trend doesn't necessarily mean the economy is shrinking. Remember that. So if you think about the sort of standard definition of a recession, it's 2 quarters of negative GDP growth. A deviation from the trend doesn't necessarily mean that GDP is shrinking or that it's shrinking for 2 quarters. All that it means is that growth is slower than what has been predicted by the trend. So that's why it's picking up. There are now more downturns in this series, for example, than there are recessions. And it's in that sense that it's a broader definition of business cycles than what used to be thought about, but also what you might think about yourself when you think about what the business cycle is. And this is important if you're going to understand sort of what comes next. And so I say this here. Now recessions or crises are just one of many deviations in the series or in the trend. And this definition is now broader than what we talked about before. And in some sense, it's now downplaying these depressions or these crises. They're no longer the thing we want to explain. They're just other movements around the trend. They're part of a sort of greater theory of these equilibrium oscillations.